Assalamualaikum warahmatullahi wabarakatuh and also good evening to everybody. My name is Muhammad Akmal bin Abdul Hadi from class DTK2A and my metric number is 01DTK21F1021. And today, me and my team going to present to you guys about presentation of application differentiation from a course of DBM 20023 Engineering Mathematics 2. And my team consists of three people, which is me, myself, Muhammad Akmal bin Abdul Hadi, Muhammad AZHARI, and Muhammad SHAHRUL ISYRAQ. We are from team or group 9. Okay, moving on to the next slide, I'm going to talk about task assignment and responsibility. So basically or technically, what it does is it helps us to decrease the amount of time that we needed to finish the assignment by giving individual tasks, or it give us um, each of us like job to do to finish the assignment faster. So as example, me myself, Mama Akmal, uh, have been given a job to make a slide about introduction of the assignment or the presentation, the task table, make slide for it, and also edit video. Next is my friend Azhari. What he did is solution or solve the equation from the mathematical equation, introduction of the differentiation, and last but not least, my friend here, Muhammad Sharul Isra, um, he make the summary and find the example of differentiation in real life. Let's go to the next slide. So what we're going to talk about in this slide is what we're going to learn in this presentation. So basically it's a simple version of what we're going to learn today. So as example is meaning of this differentiation, how to solve equation or question about differentiation equation, and third is why differentiation can be related or be related in our daily life. Okay, so that is basically what we're going to learn today. So yeah, let's move on to the next slide. Next, we're going to talk about differentiation. Differentiation in mathematics is a process of finding the derivative or rate of change of a function. In contrast to the abstract nature of theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, four rules of operation, and a knowledge of how to manipulate function. As you can see, this is the three basic derivative, which is algebraic function, trigonometry function, and exponential function. Okay, let's go to the next slide. Alright. So next one, or the last but not least for me, for my section, I'm going to talk about what is differentiation. So basically, differentiation allow us to find rate of change. For example, it allow us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of a y against x is the gradient of the curve. There are a number of simple rules which can be used to allow us to differentiate many functions easily. So that's all from me, Muhammad Akmal bin Abdul Hadi from class DTK2A from group 9, and that's all from me. Thank you. Bye bye.
Example of application of differentiation in real life. In business, today usage of derivative has seen to development of multiple strategy into which company incorporate derivative. They use hedging through derivative is still highly prevalent. Companies both in and out of the financial industry has begun to use derivative as a method of speculating and generating income. Arbitrage firm has also started to use derivative as a method of creating arbitrage opportunities. For your information, arbitrage is the simultaneous buying and selling of currency or commodities in different market or in derivative form in order to take advantage of different price for the same asset. Other example of application differentiation in the real life. In games, if you don't understand derivative, you will be bad at mining game. As example, first person shooter, when you shoot moving enemies, it's very easy to miss. So you need to predict where they might be in the next moment and then shoot there. How will you predict? You predict by checking out direction and the speed of their movement, the derivative of their movement. Then when you predict their eventual location, you are unintentionally doing a mental integration. That's how you predict their movement and get your shoot. Practical application. This tool is not just limited to mathematical problem. It has a broad range practical utility. Nothing is useless in this world. When we say something cannot be used, we actually don't know how to use it. The one who knows its utility will not stop thinking about it. The uniqueness of this concept is predictive ability to evaluate change in quantity, whether it's speed, momentum, temperature, and even the business speculation. All the variation can be worked out using derivative.
Okay, firstly, I will read the question given to group 9. The question is, the graph of a curve with equation y equal 2x cubed minus 3x squared minus 12x plus 4. And firstly, and A is, use differentiation to find expression for gradient of a curve dy dx. So firstly, to answer this, we must first find what the equation is. And the equation given to us is y equal 2x cubed minus 3x squared minus 12x plus 4. And using differentiation, we will get dy per dx equals 6x squared minus 6x minus 12. So next, to find the coordinate of any stationary point on the curve. So now we already have equation of dy per dx equals 6x squared minus 6x minus 12. So for a stationary point, dy per dx is equal 0. With this, we can use factorization on 6x squared minus 6x minus 12 equals 0. With this, we can get open bracket 6x minus 12 close bracket open bracket 1 plus x close bracket equals 0. With this, we can find 2x, which is the first x is 2, the second x is negative 1. But now we must find the y. So when x is equal to, we must replace the x on the equation y equal 2x cubed minus 3x squared minus 12x plus 4. We must replace the x with 2, which means the answer when x equal to y is negative 16. Meanwhile, for when x equal negative 1, y is 11. Therefore, the stationary point are 2, negative 16, and negative 1, 11. Now we are on D, which is to determine y-intercept point. To find y-intercept is to use equation y equal to x cubed minus 3x squared minus 12x plus 4, which means to find y-intercept, x equals 0. So to do this, we must replace x, we must replace x with 0, which means we'll left us with y equal 4. So y-intercept equal 0, 4. On E, to determine at nature of any stationary point you found in part C and justify your answer. Now we'll do the test, second order of differentiation. Now we already have dy per dx equals 6x squared minus 6x minus 12. And now we will do the second order differentiation. And now we got d square y per dx squared equal 12x negative 6. With this, we will use x1 and x2 we got from before, which is x1 equal 2 and x2 equal negative 1. So at the point of x equal 2, we will use the equation we got from second order differentiation, which is d square y per dx squared equal 12x negative 6. X, we will replace x with 2. So the answer we get at the point x equal 2 is 18, which is more than 0, which will be our minimum point. And then at the point of negative 1, this will replace the x with negative 1. We will get the answer of negative 18, which is less than 0, which is gonna be our max point.
Alright, last but not least, question F. Sketch the graph of the curve. So the equation that we need to use is y equals to 2x cubed minus 3x squared minus 12x plus 4. So the graph of the curve that we're going to get is graph cubic. So as you can see, this is the graph that we're going to get from the equation. Alright, thank you so much guys, bye bye.
Right now I will begin summarize the solution. In summary, we use the first order differentiation to determine standard point of function y equal 2x power of 3 minus 3x power of 2 minus 12x plus 4. The graph have two standard points, which are in bracket is negative 1, 11 and in bracket 2, negative 16. After that, we did the second order differentiation to determine the nature of standard point at the in bracket 2, negative 16. dy per dx equal to 0 and d power of 2y per dx power of 2 greater than 0. While at the in bracket negative 1, 11, dy per dx equal to 0 and d power of 2y per dx power of 2 less than 0. Last but not least, the shape of the graph is cubic curve.